Hello class, in this video we'll go over some arithmetic operations in C++. First, let's go over integer division. In C++, when you divide two integers, such as 5 divided by 2, the result will be an integer. So when you divide 5 by 2, you would expect the answer to be 2.5. But actually in C++, you are going to see 2, because the fractional part, the decimal part, will be chopped off. Again, this is an integer division. An integer division in C++ will result in an integer. Again, the fractional part will be removed. In order to turn that division into a floating point division, you have to include a decimal point in at least one of the numbers in the expression. In this case, I have changed 2 to 2.0, and then in C++, this is automatically considered as a floating point division, so you will see the answer. Right? So let's try this. I'm going to declare an integer x and assign to it 5. And then also declare an integer y, assign to it 2. These are both integer, and then here it is, cout. I'm going to say what is x divided by y, and end line, and return 0. We'll build this. This project, by the way, was created already. We'll build this, run it, and there's 2. So 5 divided by 2, an integer division, is 2. We'll OK this, and notice that I can actually now turn this. Let me also show you that you can actually do the division using the numbers. I can actually write down cout 5 divided by 2, end line, basically avoiding the variable declaration. If I run this again, you would see the same result. Comes out to be 2, integer division, right? Now, in order to turn it into a floating point division where you actually see the decimal point, either you have to turn 5 or 2 or both into a floating point number. I can say, for example, 5.0. That turns it into a floating point number, and when I run the program, you will see the first one is 2, which was 5 divided by 2, but the second one interpreted as a floating point division. Now you may ask, so how would I turn this x divided by y into a floating point division? Well, in C++ you can cast variables. So in this particular case, I can go in here and cast, meaning temporarily change the type of a variable to another type, and I can here temporarily cast this integer x into a double, right? Just in this particular expression, x is interpreted as double, so that 5 you see there, it will interpret it as 5.0 just in this expression, and then that division will be a floating point division. When I run this, you will see that you get 2.5 for both expressions. As I said, this is called casting. So you cast the type of a variable. Now that takes care of the integer division. Be careful with that. Be very careful with this, because it's something that usually students new to programming would make again, integer division mistakes. Now, let's move on to the next expression. I have this arithmetic expression, and I want to program C++ to figure out the results here. Now, if you want to compute this by hand, you know the order of operations. Multiplication and divisions are performed first, and then addition and subtraction. So looking at this expression, first you would do 8 divided by 4, which is 2. Then you would also do 3 times 5, which is 15. So you have 2 plus 2, which is 4, plus 15, that's 19 in the numerator. What about the denominator? Denominator, first you multiply -4 and 3, that's -12. You add 2 to it, that's -10. So I have 19 over -10, which is -1.9. To code this, I can write out C out. I put open parentheses, so 8 divided by 4 plus 2 plus 3 times 5. That's the numerator. Multiplication. That's the numerator, and I'm going to divide it by the denominator. And what is the denominator? It is 2 minus 4 times 3. And line. I can have this. Is this a floating point division or integer division? Well, the numerator, everything, all the numbers are integers, so I'm going to end up with an integer in the numerator, an integer in the denominator. So this is an integer division. If I run this, you would notice -1 rather than -1.9, because this is interpreted as an integer division. The decimal portion is removed. So in order to turn it into a floating point division, grab any of these numbers. All you have to do, any of them, just place 0.0 to it, and then C++ will translate this as a floating point division, and then you actually see the correct result, expected result here, and that is -1.9. Now let's look at what happens when parentheses are not placed correctly. Now if I remove the parentheses in the numerator, C++ will see this as 5 divided by the denominator. That's how C++ will interpret this. So it is very important for you to properly place parentheses. Or if I place the parentheses back for the numerator and remove the ones in the denominator, what happens? C++ will interpret this as the quantity in the numerator divided by 2 alone, and then whatever the answer is, 4 is subtracted from it, and then the whole thing is multiplied by 3. Right? So make sure to place parentheses correctly in the expression you write in C++. Now the next item is the power function in C++. Most likely you have seen the exponents in college algebra. 2 to the power of 4 is basically, this means multiply 2 by itself 4 times, which is 2 times 2 times 2, and again multiplied by 2, which is 16. In C++ there is a function, built-in function, which is called power, P-O-W, that does this for you. So I can actually, if I want 2 to the power of 4, there it is, C out, rather than writing 2 times 2 times 2 times 2, instead of writing this, let me put some space in there, I can actually write down power. I'm going to call the power function, and it has 2 arguments. The base, which in this case is 2, and then the exponent, which is 4 in this case, and end line, right? So these would produce the same result, but this is of course much more convenient to use the power function to do all exponential computation. So we'll run this, and what we see here is 16 and 16, both of them come out to be correct. But again, this is much convenient. What if you want to raise 2 to the power of 10? You're not going to multiply 2 by itself 10 times in the expression. Again, the power function is much more convenient to use basically. 2 to the 10 is 1024.